So how many types of different DC motors are there? In the last chapter we looked at different types of DC generators, and they were separately excited DC generators, shunt DC generators, and compound DC generators. Along the same lines, there are actually 4 DC motors. You have separately excited motors, you have shunt motors, series motors, and compound motors. So let's look at each one of them one by one. Separately excited motor, again remember what we discussed under generators, that the name of the motor comes from the fact that how the field of the motor is connected and how it is supplied current, or in current to establish the flux. Same thing over here. Separately excited motors means that the flux, the field is being provided current to establish the flux by another voltage source, a separate voltage source. Hence, it is not connected to the same power supply which is providing current to the armature. So as you can see over here, armature supply is separate, which is just connected to the armature, and field power supply is separate, which is connected to field, which is producing flux, which is interacting with the conductors in the armature. So this is separately excited motor, and if you want to create the block diagram of the circuit diagram of separately excited motor, it will be pretty straightforward. This is your ES, RA, and your CEMF, like we discussed in the last topics and the last few topics. This is separately excited motor where your source current and your armature current is the same, right? And this is basically, that's going to be your flux right here. Oops. Anyways, this is going to be flux, so this will be produced by the field, which is connected to a separate field supply. Now this system, this is a speed and direction control system of a separately excited motor. And this system is called Ward-Leonard speed control system, and it is a very commonly used system in practice. So in this system, basically, as you can see, you have a generator connected to a 3-phase motor which is rotating its armature. You have electromagnet which is providing flux to the generator, and this generator is basically the supply voltage for this motor. R is the armature resistance, and this is usually combined, the armature resistance of the generator winding as well as armature resistance of your motor winding. And this is a separately excited motor, so the field of the motor is connected to the field supply. Now this system is, as I said, it is used very commonly because there are many advantages of using Ward-Leonard system. So the first advantage is that the source voltage that you're generating, of course, you can change the value of the source voltage as well as direction of the source voltage. That is, you can change the direction, in which direction the current is flowing towards the motor. To change the value of the source voltage, either you make the flux smaller or the speed of rotation slower, because this motor is rotated by 3-phase motor, this armature is rotated by 3-phase motor. To change the direction of the induced voltage, hence to change the direction in which the current is gonna go towards the motor, you can change the direction of rotation of the armature, or you can change the direction of flux which is linking the armature. If you change both, of course, it's going to be the same direction in which the voltage will be induced. So you can change one of them. Now, why it is important to change the direction of current? It is important to change the direction of current to control the direction of the movement of motor. So for example, the current is going right now in this direction as it is shown. It is entering on top. So the motor will be rotating in one direction, clockwise or counterclockwise. Let's say counterclockwise. But if the current goes at the bottom and enters in the opposite direction, that is, it's coming out from the top, then the Lorentz force that will be applied on the armature, it will have the opposite direction or different direction. And due to that direction of Lorentz force, it is going to start rotating in the clockwise direction. So this system is used very commonly where you have to control the speed of the motor as well as direction of the motor, rotation of motor. For example, in your elevator system, elevators goes up and down, that is the direction of the rotation of motor, it changes. In addition to that, when you supply current in the, let's say it is moving in the counterclockwise direction or elevator is going up, if you change the direction of the ES source voltage, and current will start going from bottom instead of coming through the top, what's going to happen, the Lorentz force direction is going to be reversed. And if the motor is moving, since now the torque direction is opposite, it will start slowing down the movement of the motor. And that's basically the electrical braking system. In the electrical braking system, you change the direction of current that is going through the armature. Hence, an opposite force and opposite torque is applied on the armature, and it starts slowing down the armature. And eventually, of course, it stops. And in this case, if it's an elevator, when it stops, you will have to cut down the supply, otherwise it's gonna start rotating in the opposite direction right away, because the current is still flowing in the opposite direction. So you cut the supply. There must be a switch or something that you control when it stops, and then once it starts moving again, based on in which direction it is going, either going in the same direction or going in the opposite direction, going up or down, then the direction of ES can be controlled according to that. So this is the system. In this system, if ES is larger than E naught, like in this direction, current is going to flow in this direction. If you make ES smaller than E naught, then actually motor will start acting as generator. It will start supplying current towards the generator. So the generator basically start receiving the current and start charging the field and all those things. So in this case, motor can also start acting as a generator. In most of the applications where you have the regenerative braking system, that's the same idea. Your motor, which is connected to your wheels of motor vehicle, it basically, you change the direction of rotation of the motor, and it starts acting as a generator, and it starts supplying current back to the power supply. So in this case, motor can act as a generator, and it can supply current back to the generator if you reduce the voltage ES below E naught. And also you can apply the brakes, electrical braking system, by changing the direction of the torque which is applied on the motor. So that's your Ward-Leonard system. Example 5.3 is based on, I believe, Ward-Leonard system. Yes, it is based on Ward-Leonard system. So go through this example. The next type of motors are shunt motors. I'll just discuss it in the next video.